Daily, millions of data is transmitted between one device to another. But how does these transmissions actually work in this complex system? Let's get to know about this. But for that, we have to dig back into the history. It was the Cold War era. There were geopolitical tensions between United States and Soviet Union, which continued till 1991 from the end of World War II in 1945. In that days, the communication was really vulnerable. At that time, telephone communications were used to happen. So the Advanced Research Projects Agency, which is ARPA or ARPA of United States Defense, did a phenomenal work by developing ARPANET, which was an intranetwork and was much secure than other communication ways. It made communication really secure and easy. ARPANET was basically a packet switch network which divided data into small packets. Each packet traveled independently and reassembled at the destination. After this, multiple networks emerged in the market. Each vendor or major company designed their own network architecture. Companies like IBM, DEC, Xerox, etc. designed their own networking architectures which were vendor specific only. This means they worked within their own ecosystem only, and when it comes to communicate or interact with other systems of different vendors, it lacked that feature. This led to a vendor lock-in in the networking. There was no layered reference model. Different networking functions were implemented separately and were tightly coupled together, which led to more complexity. So, for that, in the early 1980s, the International Organization for Standardization introduced OSI model. They were working on it from 1970s to 1980s, and in 1984 they finally published OSI model. This model was a common framework for all the networking functions. It had 7 layers in it, which represented all the necessary networking functions. It helped standardizing the networking architecture and gave a common framework to reduce complexity. It also ensured interoperability, which means different softwares can operate with different hardwares without any problems. So the OSI model also helped in independent development and troubleshooting. What is OSI model? OSI model stands for Open Systems Interconnection. It is a common reference model which was introduced to standardize networking architectures and communication functions. It has 7 layers which represents different networking functions. The layers of OSI model from lowest to highest are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Each layer has its own function. Each layer communicates with the layer in its bottom and gives output to the layer above it. In today's world, OSI model is basically theoretical. It is used to understand how works in the real world, and it's not directly implemented in today's internet. The internet actually follows the TCP/IP model, which is Transmission Control Protocol, Internet Protocol model, which is way more simpler and practical than OSI model. It includes 4 layers only, but still OSI model holds important significance in networking. It helps to understand the data flows in the network. It provides a common language for network engineers. Without it, understanding network flows in the world and how data is transmitted is impossible. In the next video, we'll understand how the OSI model actually works and how TCP/IP model is way better than OSI model. How does it simplify things and provides quicker results? Thank you.